Hi, everybody. Hi, Jaquarius, Avery, Hadley, Logan, Mackenzie, Michaela, Lily, Reed, Remy, Lindley Latch, Lillian Norman, Britannic, Daniel, Mary Nancy, Aiden, Knox, Lindley Ship, Eli, Zyrian, Amarian, Kalia, Matias, ¿Cómo está hoy? Nadric, and Uriah. We're going to talk a little bit about math with regard to some basics that we've done, but we need a good review. And so I thought a good way to start that would be begin with the end in mind. And that would be to think, how would we use all this? Well, there was a very famous architect, and his name was Frank Lloyd Wright. If I can get him down here where you can see him. This is a book on him. And that's one of his most famous designs. It's a house built in a beautiful setting. They did a site evaluation. They would go in with a team and decide this is where we want our house. And then he would design the house around that. So he had to really have a command of geometry. And he was very well known for his use of angles and angularity in his designs. So that one is actually called Falling Water. And people live there. You can actually go see it. And the waterfall actually runs through and under the house. Very interesting. So keep in mind that we're always beginning with the end in mind. So although beginning stuff might seem boring and oversimplistic, it leads to greater things. And you have to have it. It's sort of like a stepping stone to get you where you want to go. So we're going to just review some terms and some symbols in geometry. A point is a single location in space. You can draw a dot to show a point. Although sometimes in drawings it does not show endpoints. We're going to get to that. But that would be a point. That would be read as point A. A line segment is a measurable thing in a drawing. It's a straight row of points that starts at one point and ends at another point. And in geometry languages we discovered this year, there's a particular way. It's sort of like learning art and foreign language at the same time. You have to do it all simultaneously, or you can't read it and you can't express it. So this would be read, if you wanted to write what this is, that's the drawing, you would write it as the symbol for line segment, which looks like that. Notice in the symbol, when you write it, it doesn't have those big fat endpoints. It's just line segment AB. That could also be reversed to say line segment BA. You can do that. You can do that with line segments and with lines. You cannot do it with array. So the next one, the difference is, as we contrast these, we see points on the end, arrows. And that means it's extending infinitely, forever, in both directions. So therefore, it's no longer a segment, a measurable piece, in other words. It keeps going in both directions forever. So that's a line, not a segment. And we would write it in geometry language with the symbol for line, which has two arrows on it. And that could be read as line AB, or you could invert it and say line BA. Both would be acceptable there. We talked about that when we took our notes. Ray. A ray is a straight row of points that starts at one point. We call that the end point, although it's sort of like a beginning point, as is the sun, the source of the light, starts there and then emanates or extends out into space. That's sort of what a ray does. Except in a drawing, it could go in any direction. But when you write it in geometry language, the symbol for ray will be pointing to the right over those points. So this could only be written as ray AB because you begin with the end point. Doesn't matter which direction it goes, the starting point, the source of the light, think of it that way, has to be written first. Ray AB. An angle. We've talked about complementary, supplementary, acute, obtuse, straight. We've done a lot with angles, so this is a basic review again. If raised lines or line segments meet at a common point, such as this, and that's called the vertex, V-E-R-T-E-X. The plural of that word is, you know what it is, vertices, that's right. Where those two rays meet is the vertex. And you would read that as, because we're measuring between the two rays now, that's the angle, the space between them. How big is the gator's mouth open, in other words? This would be read as angle CAB or angle BAC. The vertex is always in the middle. So that's why it's going to look like this. You see the symbol for angle here. It looks like a leaning L. Angle CAB or angle BAC. But the vertex is always going to be the middle letter. And we know that already. So we have already been into classifying some angles. So I thought we just would kind of do a little bit more on that, just to review. We know what acutes are. They're less than 90 degrees because 90 degrees are right angles, typically shown with the square corner. An obtuse angle is between 90 and 180. And it says it's between that because once you get to 180, you now have a straight angle. We talked about that when we were working with our protractors this year. That flat line on the bottom, that was your straight angle. Because if you put two of those together, you get 360, which is a circle. Remember? So if we look at number 1 here, you're measuring the distance between the rays. How wide is that distance? Well, it's 37 degrees. Well, that's less than 90 degrees. Therefore, I can conclude this is a what angle? Acute. This one is much more open. See the distance between the rays? That's what the angle is. And it's obviously greater than 90 because it says it. It's 135. So if it's 135 degrees, that is obviously an obtuse angle. This angle, remember, we're measuring between the rays. Although it's hanging downward, that's irrelevant. It does not matter because you can move this book around or move your head and see it's only 21 degrees apart. That's a very small angle. That's acute. There's your square corner, which obviates the fact that that is a right angle. And that should look familiar. That's your straight angle, 180 degrees. It's like the bottom of our protractor, that baseline we use. This one, 55 degrees. It's less than 90, so therefore that is acute. This is between this ray and that ray. It's pretty far open. It's 120 degrees, so therefore that is obtuse. Here again, that one's easy. It's a square corner, 90 degrees. That's a right angle. And I'm not sure you can see the bottom, so I'm going to pull this up a little bit, okay? If we're looking at line NE, and it's broken into two angles. I see this one is angle NIL or angle LIN. It's 70 degrees, so that makes that one acute. And if this straight line gives me 180 degrees, I'm in search of the value of this. Now, we would probably give it, I don't know, we could call it N, and I wouldn't tell you the degree measurement. I'd make you figure it out because we're that far now. So 180 minus 70 would give you 110 degrees. This is acute, this is obtuse. Together, those form 180 degrees, so they are supplementary angles. In this one, we have two right angles. I know that because I have two square boxes down here and it tells me they're both 90. Angle XOB or angle BOX. And then this one is angle BOY or angle YOB. Notice they have a common vertex, O, and 90 plus 90 is 180, which is supplementary. So they're supplementary angles. And if we get to our last one, angle FAN, which could also be called angle NAF, is 95 degrees. That's greater than 90, so that one's what? Obtuse, right? Because it's not much greater than 90, but anything greater than 90 is going to be obtuse. 85, slightly less. That's angle FAT or angle TAF. That is acute because 95 plus 85 gives you 180. So they're supplementary also. So as we're looking through some more designs by Frank Lloyd Wright, I thought you might like to see some pictures. Okay? And keep in mind, he designed these houses and quite often designed the furnishings that went in them. And as he visited later, he could go visit the people that paid him to design their homes. He was very picky and critical about what they did, what kind of furnishings they put in there. So often he designed that too. And he wasn't afraid to tell them so either, because he was an artist. It was living art. Notice the angles, lots of square corners, lots of 90 degrees here. Even the lines in the chair, you can see. He liked angularity, very much that way. The stained glass lighting fixture on the top, which is beautiful, has a few little curves, but not many. He was definitely an angle guy. Nothing wrong with that. I tend to like curves, but I guess you need both, because, well, where would we be without them? Look at this house, the interior of this room. Look at the lines and the angles in the ceiling right here and in the windows. Here's a triangular shaped skylight that's letting the light in here on the fireplace, which even includes parallel lines in it. You have a couple irregularly shaped ottomans sitting there and a basket, but overall very few curves, lots of lines. I would say he was very geometrically minded. I'm just concluding that. What do you think? In this one, we see, believe it or not, a kitchen dining area. Look at the ceiling. Look at all of the lines intersecting. Rectangular prisms in the light fixtures. The windows are rectangular. The cabinets, they have parallel lines in there. The countertops. The fireplace is one tall rectangle. Then you have more lines here on the fireplace. Look at these windows over here with these parallel lines in it. Then you have a staircase, which is kind of a floating staircase going upstairs, all parallel, but we don't see the backs of the stairs. And we also don't see a stair railing. And that's so that our eye can look through the stairs and still see the architecture of the room. So obviously, you can see the artist's eye in his work, and geometry is everywhere. So, when you think about geometry, don't just think about points, rays, lines, line segments, and space figures and plane figures. Think about what can you do with that. If you love working with it and you're artistic, maybe architecture is something you can go to later in life. And with that, I'll talk with you soon.